All right, good morning. Welcome back to PreCalculus. So we are going to talk about systems of equations here, and these are nonlinear equations. One of them is linear. So what the system looks like to me is we have some sort of a line, and then we have some sort of a parabola here. Okay, so that's how we do that one. So what's the possibilities, right? We have a line of parabola, so it looks like we have, could we graph this parabola? We could. How carefully do we want to do this? All right, this is going to be a 5x minus 1 times 5x minus 1. I think that'll do it for us. But we pretty much have a parabola. We have x squared, so we have something like this going on here. And then we have 5x plus 5, or y plus 5x here. Y plus 5x equals 4. You're going to graph stuff like this a little bit more often. Set x equal to 0, y equals 4, set y equal to 0. We have 5x equals 4, so x equals 4/5. Okay, so we have x equals 0, y equals 1, 2, 3, 4. Okay, and then set x equal to 0 and or set y equal to 0 rather, x equals 4/5. So we're over here somewhere. So we're going to end up with something like that. Okay, so it could hit in two different spots. This line could completely miss this parabola. That's a possibility. It could touch it at one point as a tangent line. That's fine. Excuse me. And those are pretty much our options. So if we get one solution, we know it touches in one place. If we get no solutions, we know it missed. And if we get two solutions, that means we intersected in two spots. Okay, I'm not going to get more. All right. There's no way to wrap this line around this parabola, so we could hit it in three places. Okay, so 0, 1, or 2 solutions is what we expect. And then we'll go ahead and solve. So I've got y plus 5x is equal to 4. So we'll go ahead and write that down. So we have y plus 5x is equal to 4. And I've got 25x squared plus 30x minus y equals 14, negative 14. So in this case, let's say, you know what, we have a minus y. Okay, so could we do that here? Could I shuffle and say something like negative y minus 5x is equal to negative 4? All I did was multiply everybody by negative 1. And then we could say something like negative y is equal to 5x minus 4 by adding 5x to both sides. Okay, there are dozens of ways you could have done this the same way. Why am I substituting for negative y? Because this equation has a negative y in it, okay, which is fine. What if I just didn't want to distribute the negative sign? So we have 25x squared plus 30x plus a negative y. Well, what's negative y? That is 5x minus 4, and this is equal to negative 14. Okay, so we can go ahead and do that. So it's 25x squared plus 35x minus 4. Actually, I'm going to go ahead and add 14 to both sides. Okay, so negative 4 plus 14 is, it looks like we're going to have a negative 10 here. No, we're going to have a positive 10, sorry. So we're going to have a positive 10. All right, so just double checking. I am not good at doing this, so equals 0. One of the things I do notice is that everybody's divisible by 5, so that might be one thing we can do, is divide or multiply everybody by 1/5. So we can have 5x squared plus 35 divided by 5 is going to be 7x plus 2 equals 0. Okay, and 5 times 2 is 10. Can I think of two numbers that multiply out to 10 but add up to 7? How about 5 and 2? So when I was talking about, hey, this AC method business is not going to go away, I was not lying to you. Okay, so all I did was multiply the first and the last. That's 10. 5 times 2 is 10. Take a look with two numbers. That's 5 and 2 makes up 7. 5 plus 2 is equal to 7. That's how we get this to be equal to that. So I'm going to pull out a 5x here. So what are we going to have left? We have x plus 1 plus 2. What do we have? We have x plus 1. Okay, so what we're going to do is sweep through the x plus 1s. So we're going to have x plus 1 times, what is this? 5x plus 2 equals 0. Now we can go ahead and use our zero factor principle. Okay, so we can say this is x plus 1 is equal to 0, so x equals -1. 5x plus 2 equal to 0, x equals -2/5. By the way, this method of intercepts that I used up here, this is a really, really powerful technique. Okay, I remember taking engineering classes and having the teacher do this without really explaining what they were doing, just kind of did it, and the rest of the class looking at it like, ah, that's absolutely magic. Like, no, it's just method of intercepts. So when you guys go ahead and take your higher level classes and you still remember this, you are going to be seen as like you're going to be like you're going to feel like the smartest person in the room if you remember how to do this. I'm not kidding. Okay, it's such an easy thing that we have to do. I would urge you, like, when you have the ability to do that, that's a very powerful technique. Okay, now we have x equals -1, x equals -2/5. Hey, take your pick. Okay, you could plug it into either one of these two equations and get what y is going to be equal to. I would recommend the first equation. Okay, so we're going to say y plus 5x is equal to 4. Could I go ahead and say, okay, well, y plus 5, what's x? -1 is equal to 4, so we have y minus 5 equals 4, or y is equal to 9. Okay, this AC method is another one of those things where, like in math classes like this, even when you get to calculus, calc 2, if you could factor by AC method, you're going to be seen as such a smart student, such a capable student compared to your peers. It's going to be, why do you not know this? Well, because it wasn't. That's why I keep asking it, because it's not enforced. Okay, so we have y plus 5. What the heck is x? In this case, it's -2/5. Well, that's convenient. Equals 4. Okay, so we have y. This cancels. -2 is equal to 4, so y is equal to 6. So our pairs. Okay, our pairs. We have -1, 9. That's one intersection point. And then we have -2/5, and then 6. Okay, those are our other intersection point. Okay, so those are the two values that we're going to be looking at. So let's see here. They are going to be, so we'll go here and we'll say or. Okay, we can do it that way. Okay, normally I would have like set notation for this, but whatever. That's how they're going to do it, which is the curly. So I would write this as, here are 2 points that satisfy the solution. Okay, we could do it that way. Okay, so we're going to have -1, 9. Okay. And then honestly, I tell my face-to-face class this a lot. I told some of my other classes this a lot too. It's like you are going to be your friend. You're going to be the person on the job that is supposed to be good at math. Okay, it's a terrible burden. They're going to ask you questions like 3/4. Could I say this is 3 times a fourth? That is a question you're going to answer on a regular basis. Okay, so knowing some of these easy tricks or some of these very simplistic tricks, you can think, you can't be serious. People are not going to ask. I'm like, yeah, they will. And if you know how to do it, you're just going to be seen as that much more capable of like, oh yeah, just do it this way. And then people are going to say, wow, you saved the day for this one. Or, we lost the teacher when they did that method. I'm like, how did you know that? Just tell them. I've just always been that smart. Okay. So there you go. That's how you do this problem, this kind of a problem. And again, it's very, very typical calculus problem of things like, we have a parabola here, and you have a line that probably does something like this, where it's going to say find the area between the line and a parabola. So if you know these 2 points, you'll be able to figure that, you'll be able to set that calculus problem up very easily. I know it looks like it's a hard thing now, but it really is. Once you have these 2 points, it's a very easy problem with calculus. So good luck with that. Please try a couple of these. This is a very recurring theme in calculus, and some of the other techniques you do in this are going to come in useful over and over and over again. Okay, thanks for coming along for the ride, and I will see you next video.